Thank you for tuning in today, and I'd like to also thank the organizers of this session. I'm going to be presenting work that's being conducted by me and students in my lab and the labs of my colleagues at the University of Georgia. I would also like to begin by acknowledging the collaboration of both current and former employees of Athens-Clarke County and regional collaborators such as the Metro Water Planning District, Danny Johnson, for their support in this work. I'm going to be ending this conversation with a discussion about new work that's going on in our labs, which actually involves individual homeowners, which some of you can see their parcels delineated as part of Athens-Clarke County. And as a freshwater ecologist, what I'm really interested in is understanding what is driving nutrient and energy flow into aquatic systems and how this ends up altering the quality and quantity of freshwater resources. And one of those big drivers that we haven't been able to really explain are non-point sources of pollutants, of energy, of nutrients that are coming into freshwater systems from our wastewater treatment infrastructure. And oftentimes when we're thinking about failures in wastewater infrastructure, when they get covered in the news, they're funny. And so this is an example of this. I believe you can still access this story on NPR's website. But it was coverage of a train that was filled with wastewater from New York that ended up in Alabama and was stranded and causing a great stench in a local community. And while that can be humorous to think about, it really made me a bit perplexed in understanding why on earth wastewater from New York ended up in Alabama. And it highlights, a critical problem that we have with aging and obsolete infrastructure, and kind of the basic fact that the general public is really not aware of how tenuous a situation we are with the state of our infrastructure. And this may be challenging with things like Flint, Michigan, and other environmental concerns like the water being shut off in Toledo from harmful algal blooms, or even this week with boil water warnings being sent out across the city of Houston, which you can see mapped here. I think that we are becoming more aware of how the state of our infrastructure and how that can compromise at minimum human health, but we're also seeing environmental impacts, and those are coming more to the forefront in news, I think. The American Society of Civil Engineers, which if you have been listening to the news this week in reference to what's going on in Texas, you know that they put out a report card, and nationally, all of our infrastructure is obsolete and aging. And water infrastructure, both drinking water and wastewater, received a D on this grading structure, which is a traditional A to F grading structure. And what that means is that most of our infrastructure is in fair to poor condition, most of it's below standard and at serious risk for failure. We have a lot of water infrastructure in this country, and that is expected to grow. So this is just sewerage lines for what we're talking about here, and drinking water lines. The burden on our wastewater systems and our drinking water systems is expected to grow in the upcoming years, and it is already a system that's facing a lot of failures with, for example, water main breaks. The gap in paying for these, the needed changes to our infrastructure is large when you think about what the potential federal investment is expected to be versus what actually needs to be done. And this suggests that local and state governments are going to be expected to pay the bill to support this infrastructure change. And in response to what happened in Flint, Michigan, there was an article in Politico that tried to analyze the investment into water infrastructure. And you can see here in the light blue bars, that's documenting the total amount that state and municipal governments were investing into water infrastructure. And the dark blue is the federal investiture in water infrastructure. And what you can see here is, in general, the distance between those two bars is growing through time, suggesting that the proportion of money that the preponderance of the money that is going to be spent on this investiture is at the state or local governments and level. And so what that means is that these jurisdictions need to have the data they need to make smart choices about investing this money. It's a lot of money. Problems with aging and obsolete infrastructure are fairly ubiquitous, and so they need to be able to mitigate risk and manage their investment accordingly. But again, most of this infrastructure is underground. And in the case of decentralized wastewater, this is not even typically governed, or there are no fees in many jurisdictions associated with maintaining a septic system on your own property. Therefore, a lot of the questions that we have go unanswered because wastewater is often out of sight and out of mind. But as a freshwater ecologist who's interested in understanding the biological response to what's going on around freshwater systems or within watersheds, I need to have a better understanding of how the infrastructure is interacting with freshwater resources to really be able to model how freshwater systems are going to change with increasing anthropogenic pressures. And this means both the quality and quantity of freshwater resources that exist for human use, but also to be able to predict what's going to happen for animal and plant species that we care about that live in these systems. When I got into the weeds of this, though, when I started really thinking about what this meant, I also realized that my system is not as complex as it actually needs to be. And it actually involves the social system as well, which includes the local government, stakeholder engagement, the amount of information that's available. And all of that coupled is going to influence management decisions, which feed back into the biophysical system, both infrastructure and the environment, which will produce a situation in these freshwater systems that are going to lead to socio-environmental outcomes such as the structure and function of freshwater systems, but also human health. And in particular, what I and a bunch of colleagues who are more biologists or soil physicists or biogeochemists are interested in doing is really being able, helping support these management decisions so we can preserve the quality and quantity of freshwater resources that we have into the future. And so the work I'm going to talk about today is really our work primarily with Athens-Clarke County that we've conducted to really support local governments in making proactive decisions to address potential failures in wastewater infrastructure. Now, septic systems also add an additional layer of complication. They are below the surface, but once they are installed, they typically are completely managed and monitored by individual landowners or the parcel owners. But the problem here is that if you have if you have a massive failure of a single system or just kind of obsolete infrastructure failing below the surface and allowing untreated water to get into the groundwater, you can start having effects on larger watersheds that are being governed by management decisions at the household level, which adds a whole other complexity. When you think about how certain cities can be situated within watersheds, for example, Atlanta, as you can see here, infrastructure decisions about Atlanta have the potential to impact many state-level waterways in Georgia. And if we start thinking about expanding these problems throughout the country, we can see that decision-making at the local government may in fact have much larger effects on other jurisdictions because of this watershed connection. And so again, I just want to highlight that all of the work that I'm discussing today would not have been possible without massive investiture and collaboration with Athens-Clarke County. All right, so septic systems. What do we know about them? Well, we know that they are supporting wastewater treatment for a large proportion of homes in the US, but this is heterogeneous. We also know that they are still commonly being put in the ground, and about 40% of new developments are actually based on septic. Data very limited data, suggests that the lifespan of septic systems should be about 20 to 30 years, and they should be pumped every 3 to 5 years. But other data suggests that maintenance is not common, and so aging and obsolete septic systems, we think, present large risks to the quality of surface water resources. So septic tanks can fail in a couple of ways. One, they can back up into the house, which usually inspires a homeowner to call and get help. They can also bubble up outside, causing raw, untreated sewage to come out to the surface, which also oftentimes inspires a homeowner to ask for help. And when this doesn't, if neighbors or anyone else can see it, the public health department can be called in to address this failure. But what is not commonly understood are these subsurface failures of septic systems, where untreated water might be entering the water table and then getting into surface water. And so we need to understand these things to be able to start understanding and modeling how non-point surface pollution may impact surface waters. But still, most jurisdictions don't have a good understanding of even where septic systems are, what condition or maintenance histories they have, and because of this, they can't assess the potential risk for septic failure. So the challenges in designing proactive management strategies include a lack of data and records, or at least online records. So a lot of these records are stored, but they're stored on paper. And it's resource intensive and it's expensive to develop these. So community university partnerships allow or create this opportunity to address some of these issues. So the purpose of the study that I'm going to discuss next was to really help to create a tool that would support local governments in assessing the condition of their septic infrastructure. And so again, we used a data set that was largely curated by Athens-Clarke County, and we integrated those data with environmental data to hopefully develop this tool. This was published in Environmental Science and Technology, and I've included the reference here if it's of interest to you. But the bottom line is we wanted to be able to use information from a rich data set generated by Athens-Clarke County to potentially develop a tool that could be applied to other communities to make some sort of prioritization system for on-site treatment, on-site waste treatment infrastructure. And so what we first did is we took the septic tank layer that was generated by Athens-Clarke County, and to clean those data, we looked and made sure that we only kept tanks with installation data associated with that tank, so we could get an estimate of the age of the system. Anything without, we removed those data. Then we went in and we removed any sort of parcels that had multiple tanks that were not explained easily. For example, trailer parks might have multiple systems on a single parcel, and we removed any inappropriately placed multiple tanks. And then lastly, we took this subset of data and we actually went in and, using Google Earth and other tools and going into the actual individual records, double checked for tank location accuracy, and then we were left with our final data set. And what that meant, again, because of this amazingly curated data layer generated by Athens-Clarke County, was we started out with almost 10,000 systems, and we were left with over 9,000 in our database. Then what we wanted to do is assess the potential risk that these systems pose to the environment. Again, we don't have data on individual septic function, so this is a way to identify potential risk. And the way we identified risk were, one, tank age. So we have those installation data, and we used the year 25, so it's between 20 and 30 years, the average lifespan of a tank. So we picked anything older than 25 was a potential risk. And then we also looked at environmental variables that may make certain systems, because of their placement within the landscape, more risky. And this included soil suitability, slope, and distance to stream. I just wanted to take a minute and highlight that Athens-Clarke County has many smaller watersheds within it, and septic systems are distributed throughout those watersheds. And when we looked at the data, again, tanks, 69% of the tanks in this data set were over the age of 25, suggesting that age might pose a much greater risk. That was not the case with the environmental placement of tanks. For example, only 8% of our total data set were at risk from the environmental categories we were using for placement, and most of these were on less than suitable soils. So again, it seems as if in Athens-Clarke County, the primary risk is this aging and obsolete infrastructure that's derived from a preponderance of old tanks. And this is not particularly surprising, and I would argue we would probably find this in most jurisdictions because it does require some sort of legal documentation to put in a septic system. And so anything that the county knows about should have been placed legally. And I think that's what we're seeing here. When you map all of those things, this is what ACC's known septic infrastructure looks like. And so you can see that not surprisingly, there are tanks of clustered ages. Again, most developments go in at about the same time, and so tanks that are about the same age will be nested together. And that's not particularly surprising. But the first time I actually saw this map, what did shock me was how complex underground our wastewater treatment infrastructure is, especially these septic systems that are nested within sewerage. And this is not surprising and is probably exceptionally common where septic is common, because as cities expand, they're moving from or converting previously rural environments into more urbanized environments, and that kind of swamps in and creates this mixture of both septic and sewage infrastructure, all being nested together. But what the other thing we wanted to do again is most counties, most jurisdictions don't have very good maps of their septic systems. And so in ACC, I think with our data cleaning, we can demonstrate that the county has a really good understanding of the condition of at least the age and placement of the tanks they know about. But are there potential parcels without these data, and could a different set of tools be used to predict where septic systems would be in jurisdictions that don't have an existing septic layer? So we used the ACC data to test this method. So basically what we did in Athens-Clarke County is we identified parcels without sewer connections, assuming that if you have sewer, you probably don't need a septic, and we removed all of the parcels with sewer connections. Then we, on top of that, removed the parcels without sewer but did have buildings, assuming if you have a building, you most likely need wastewater infrastructure in that building, and we removed those, any parcels without buildings from the data set. And then Athens-Clarke County categorizes different types of buildings in different ways. And so we removed any parcels without sewer but that did have permanent buildings from the data set, and then we were able to classify parcels that potentially contained septic systems. So using these data, we were able to successfully predict where a great proportion of our septic and our sewer existed. And you can see from this map, we were not able to classify the parcels with unknown water infrastructure. So in general, this method did allow us to classify areas where the county should probably go out and check to see what's going on with wastewater infrastructure on these parcels. But it did do a fairly good job of predicting where our septic and sewer infrastructure existed. Now, I do want to comment on the parcels that were identified with both septic and sewerage. In most cases, this is not surprising because, again, if you think about that map, the expansion of the sewerage left septic systems nestled within sewer connections. So we were basically able to, again, with this data set from Athens-Clarke County, potentially develop a tool to help other communities locate their septic systems. And other colleagues, including co-authors of this talk, are really working to develop additional tools to enhance the ability of local communities to be able to identify their own potential septic layers. We were able to assess using these data and predict what type of risk these tanks might pose, but I still want to highlight that we don't have the basic data to actually put failure numbers or the predicted failure potential of each of these systems and attribute that to environmental or age demographics. And that's where we're headed now with our research, and we're very excited to work on that. And this is part of it. As I mentioned, we have several projects that are funded, and one of them is comparing the water chemistry within leach fields to paired sites outside of leach fields from different parcels with septic systems on them of different ages in Athens-Clarke County, and you can see some of them numbered here. And this is direct stakeholder engagement because we have to get permission from an individual homeowner to be able to work on their land. And it has been overwhelming, the positive feedback we've received from the community and the interest people do have in assessing their septic systems. And so this kind of highlights that our collaborations at the local level, at the municipal level, have been incredible, and they've allowed us to move really far ahead. But really where the forefront of our understanding of decentralized wastewater infrastructure management is lying is with individual homeowners, and then working together with the local government to scale up our findings to larger septic sheds, to larger watersheds, and then to municipal planning. And so I just want to conclude that the state of global infrastructure is troubling. And the reliance on septic is increasing, and this is very true in the United States. Septic systems can be very effective, but we need more data to inform management and monitoring efforts, especially as our systems are aging out like they are in Athens-Clarke County. And community engagement in research on decentralized waste infrastructure in the United States is completely dependent on stakeholder involvement because, again, unless septic systems are spewing untreated waste into the environment, the management and maintenance of those systems relies with an individual parcel owner, and so it requires this type of engagement. And if you are interested in learning more about the collaborative research that we're doing, we've called ourselves the BioGeo Poop Group. You can go to this website and learn more about our work together. And if you do have any interest in collaborating, we'd love to hear from you. Thanks so much.